In today's lesson, we are going to recap the topics related to inheritance and polymorphism. First, let's go ahead and talk about the whole idea behind superclass and subclasses. So inheritance is going to define a relationship between objects and how they share their characteristics. We can say that a subclass is created from an existing class, and this subclass is going to inherit all methods and instance variables from its superclass. Because of that, a subclass is actually bigger than a superclass because it contains more data and more methods. It's a great way to reuse code. It's also another way to have hierarchy among our classes. It uses what we call an is-a relationship. Public methods can be used by any descendant of the class, even if those methods are not overridden. Private instance variables are allocated, meaning that they have memory set aside for them, but it's not directly accessible by the subclass. So these subclasses have to still use access methods in order to use the variables and call the superclass constructor to initialize these variables when the object is created. We use the keyword extends to create a subclass. Method overriding. This is when a subclass method can go ahead and override a public method that it inherited from its superclass. We go ahead and do this by defining a method with the same method header. So it needs to have the same name and the same parameter types. The compiler is always going to look in the current class code for this method. So if it finds it there, it just uses that code. If the compiler doesn't find the method in the current class code, then it will look up to superclasses and travel up the hierarchy to try to find the method. If you want to specifically call the superclass version of the method, then you need to tell the compiler to do so by saying super dot and then the method name. It's important to note that private methods cannot be overridden, and that's because we cannot directly access them. When you create a constructor of a subclass, you often want to initialize those private instance variables of the superclass. In order to do this, we are going to make a call to the superclass constructor as the first line in the subclass constructor. We do this by just saying super and then passing in any parameters that are needed. It always has to be the first line of code. If super isn't called, then what happens is the compiler will automatically call the default constructor of the superclass. Now this is a very important note to make because if the superclass has at least one defined constructor with parameters, then the subclass is required to explicitly call super and call this constructor. If you don't, you will get a compile error. So it's always a good idea, a good rule of thumb, to declare at least one constructor for subclasses because constructors are not inherited from the superclass. Now, when we're declaring objects with a superclass reference, it's very specific about what we can and can't do. So a reference variable can refer to any object of its type or of its subclass. So let's say, for example, we have a class student, and the student has two subclasses, grad student and undergrad. And I can make these reference variables student A, B, and C, and student A can point to a new student, student B can point to a new grad student because grad students are students, and student C can point to a new undergrad because undergrads are students. All of this is legal. Now here's the tricky part. Variables A, B, and C, the computer just thinks of them as students. So they can only invoke methods of the student class, okay? So they can only invoke methods of the student class. If there is a method that this class wants to call that happens to be specific to grad student or specific to undergrad, then it cannot be called without a cast. If we tried to execute that, then it would give us a compile error. Now, let's say there was a method that was declared in the superclass that was overridden in the subclass, then what would happen is that the computer would determine that yes, I could call that method because the student had it, and then when it actually went to execute the method, the compiler would go ahead and it would call the method for the type of object that the reference is actually referring to. And that powerful skill is what's called polymorphism. So polymorphism, this is when a method has been overridden by at least one subclass. It's said to be a polymorphic method. And polymorphism is the act of selecting the appropriate method for a particular object in a class hierarchy. So the method call is determined by the type of the object, not the object reference. So if we consider this previous example that we just had, when the code is compiled, the compiler would basically determine if the code was valid by looking to see if the student class has the method called getGPA. And if it does, it's valid. If not, it won't compile. Then when the code is actually ran, the Java virtual machine is going to determine what object A and B are actually pointing to. And then when it gets to that object, based on what type of code it is, it will actually look at that class code and determine which version of the getGPA method to actually run. And this selection, determining which code to run based on the object reference, this is called dynamic or late binding, and it's one of the cool things that polymorphism allows us to do. Now, if the method call is determined during compiling because it's not a polymorphic method, then that is called static or early binding. And this is when methods are not polymorphic or overloaded. So the compiler knows exactly which method to do. All right, so here's an example that we will talk through a little bit more in detail in class. So go ahead and read through this example, and then we will talk about this tomorrow in class. All right, so downcasting is when we sometimes have a generic reference that is going to point to a specific object. And we will do this when we want to have, for example, an array of students. And we might have lots of students, grad students, undergrad students, elementary students. So we have a generic array that can hold specific objects. Well, when this happens, if we try to call a method that only existed in a subclass, then we would get a compile error, even if the reference points to that type of object. And that's because it doesn't know. The compiler only knows what type of reference variable it is. It does not know what type of object is at that location. And so that's why we need to use a cast. So the way that casting works is if we were to take a look at this scenario here, if we have this grad student, and let's say grad student has a method that's called getID, if I tried saying s.getID, this would give me a compile error because S, which is a student reference, does not have a getID method. However, if I were to first cast S as a grad student reference, then what's going to happen is that it will think of it like it's a grad student, and then when it goes to that object, because it is a grad student, it will go ahead and it will get the method. Now, if you take a look at the code that's written in these two ways, the middle way has the right intention, but it's still going to give us an error. And the reason why is because this dot operator has precedence over the cast. So the way that we need to do this, the correct way, is this final way that we see down here. So we need to put the cast in parentheses before the dot. And what that does is it fully casts the reference variable as a grad student, and then it allows us to call the method. And if you try to do a cast for an object which it's not an instance of, you'll get a class cast exception at runtime. All right, here's just a little extra reading that you can do to help further your knowledge base. All right, almost done here. Abstract classes and interfaces. So an abstract class cannot be instantiated, and an abstract class has the keyword abstract used in the class header. It essentially provides an outline for a class which other classes can inherit from. Abstract classes can have instance variables, regular methods, and abstract methods. They may or may not have constructors. Even though you cannot instantiate an abstract class, the constructor can be used by subclasses to give values to private instance variables. So we can make an abstract class abstract without having abstract methods. Basically, the keyword abstract is there just so that you are preventing somebody from making an instance of this class. Here's an example of what an abstract class header would look like. Here is an example of an abstract method. Now, an interface is a collection of public abstract methods. So any class that implements this interface must provide code for these methods. Just like how a subclass of an abstract class has to provide code for those abstract methods. A class can implement more than one interface, but can only extend one superclass, and the extends keyword must precede the implements clause. So here are a couple different ways that we might see this. Here I'm showing the implements clause, and here I'm showing if I extend a class and implement an interface. The syntax to create an interface is very simple. It's just public interface and then the name, and then we just have a collection of those methods. All right, last but not least, what is the difference between abstract classes and interfaces? So an abstract class would be best for an object that is specific to a certain application. So for example, if we were doing a battleship game and we had a ship class, but it's incomplete without subclasses to give further definition. So if I said it was just a ship, you might say, well, what kind of ship? How big is it? What does the ship do? Ship might be too vague, but it's a great place to start from. It's a great place to inherit from. An interface is best when multiple unrelated objects could share method names. For example, we've seen the flying interface. So birds and bugs and planes and skydivers, those are all things that could fly. So if I had an interface for a flyer, and I could have methods that are related to flying, all of these objects could implement the flyer interface. Some key differences are that interfaces cannot have instance variables, and you cannot instantiate an instance of an interface or an abstract class. So, alrighty, thank you.